Okay, so we're going to have a look at index laws in this video, and a lot of these questions do build upon all of the things that you've learnt at GCSE, so I'm going to link all the GCSE videos below. You need to have a really good understanding of negative and fractional indices, and I will make sure that that is all linked below, okay? And a lot of those GCSE questions are going to be really important still when looking at these specific index law questions that we're going to have a look at today. But grab a piece of paper, grab a pen, make some notes, I'm going to have a look at some of these questions. Now for this one here, it says simplify this fully, and inside the bracket we've got 32x to the power of 5, and then outside it's all to the power of negative 2/5. Now obviously when it comes to these negative fractional indices, the negative there is going to do the reciprocal, the 5 on the bottom does a fifth root, and the 2 on the top is a normal power of 2. And both of these pieces we have to do to that power. Now when it comes to the 32, we can think about the 32 on its own for the moment, and we can do 32 to the power of negative 2 over 5. Now we can sort that out and deal with that first. Now the negative obviously flips it over, but before doing that and doing the reciprocal, I'm going to do the fifth root of 32. Now the fifth root of 32 is 2. Okay, so 2 times 2 is 4, times 2 again is 8, times 2 again is 16, and then times 2 again for that fifth time gets us to 32. So to start with there, we'll do the fifth root. I'm just going to write this down here, fifth root. So that's 2. Then we're going to have to square it because we've got the 2 on the top, so we need to do 2 squared. So that becomes 4. And then if I do the reciprocal there, it becomes 1 over 4, and that's what that negative power does. So that 32 there is going to become 1 over 4. So if I write that down to start with, I can write down 1 over 4, and then we'll deal with that power. Now when it comes to the x to the power of 5, we can obviously multiply the powers when we've got brackets like this, so we're going to multiply these powers together. So we've got 5 lots of negative 2/5, and 5 lots of negative 2/5 will be negative 10/5, okay, just multiplying that numerator by 5, and negative 10 divided by 5 is negative 2. There we go, so my power is going to turn into negative 2. So I can write that out here. We've got then x to the power of negative 2. Now technically that is the answer, that would be fine, but there are other ways of writing this as well. And obviously we can write this in a slightly different way, because x to the power of minus 2 can also be written as, I'm thinking about this over here, x to the power of minus 2 can also be written as 1 over x to the power of 2. Remembering that that negative power there does the reciprocal, so it's 1 over x squared. So I mean, we could actually write this in a different way. If we imagine x to the power of minus 2 as 1 over x squared, we've got a quarter. Remember, these are getting multiplied together, so it's a quarter times 1 over x squared. And if we multiply those together, we get 1 over 4x squared. Now for this particular question here, it does just say simplify fully, so we can write it in any of either of these ways, but it might be for whatever reason we might want to just write it as a single fraction. So it's always good to be able to know how to write these in different ways. So there we go, we can also write it as 1 over 4x squared, or we could just leave it as a quarter x to the minus 2. But there we go, that's how we're going to approach some of these questions. Let's have a look at a slightly different one. Okay, so this question doesn't look very nice, but you're going to see we're going to treat this in a very similar way to what we did before. Now again, ignoring that x squared for the moment, let's just deal with what's in the brackets. Now everything in the brackets there is to the power of 2. So we've got the 4 that we need to do to the power of 2, and that's easy enough to do. 4 squared is 16, so we've got 16 there in the bracket. And then we can multiply these powers that are in brackets as well, or times them. And if you multiply negative a half by 2, you get negative 1. So that's going to be 16x to the power of negative 1. And again, obviously, you can write that working out down to the side. You've got minus a half, and you're going to multiply that by 2, or 2 over 1, which comes out as minus 2 over 2, which is minus 1. There we go. So there we go, that's how we can get our power, obviously just thinking about negative a half times 2 is negative 1. And now we can obviously put that in a bracket, and we can think about that x squared on the outside. There we go. So obviously when we are multiplying, obviously thinking about the fact that the coefficient of this x squared on the front is 1, and then we just multiply this bracket out. So 1 times 16 gives us 16. And then we've got the x squared times the x to the power of minus 1. And remember, obviously, when you're multiplying with powers, you add these powers together. So we're just going to add those two together. So x to the power of 2, add the x to the power of minus 1, obviously just the powers there, becomes x to the power of 1. There we go, so 16x to the power of 1. And obviously we don't need to write the power of 1, so we can just write that as 16x. And there we go, that would be our final answer for that one. There we go, so something that looks quite nasty actually simplifies down to something that's nice and simple for us. But there we go, we're going to have a look at one more question before you have a practice on some of these. Let's have a look. Okay, so this question here really doesn't look very nice. We've got 25x to the power of 4 all over 4, and that is all to the power of negative a half. Now again, I want to treat it just like I did before, so what I'm going to do is, rather than writing it as a fraction like that, and there are different ways that you can look at this, I'm going to split it up, and what I'm going to do is I'm going to write it as 25 over 4 instead. So instead of it looking like that, I'm going to have 25 over 4 x to the power of 4, which means exactly the same thing. There we go, and that's all to the power of negative a half. Okay, and that just allows me just to treat it in exactly the same way as before. Obviously this coefficient of x to the power of 4 here is now a fraction, but that's not a problem. Okay, we'll just treat that fraction in the same way that we would normally. So let's have a look then. We've got 25 over 4, and that all needs to be done to the power of negative a half. So if I write that out, look, negative a half, and that's nice and easy for us to do. Okay, that's just nice, like GCSE style question there. The negative flips it over and makes it 4 over 25. And the half there's a 2 on the bottom, so these both need square rooting. So if we square root them both, we get 2 on the top and 5 on the bottom. So that piece at the start then is going to turn into 2/5. So we get 2/5, and we've got x to the power of something. And just remembering again, we're just going to multiply these powers out. So for the power there, we have 4 that we're going to multiply by the negative a half. And again, 4 is 4 over 1. And if we times them together, we get negative 4 on the top, 2 on the bottom, and negative 4 over 2 is just negative 2. There we go, so our power is going to simplify down to negative 2. So we have 2/5 x to the power of minus 2. And again, that is a perfectly fine answer. That is fully simplified there. But again, just like that first question we looked at, we can actually write this in a different way. So x to the power of minus 2 is also the same as 1 over x squared. Remembering the negative power there just does the reciprocal, and then it's still to the power of 2. I don't need to put the power of 2 with the 1 on the top though, because 1 to the power of anything is always just going to be 1. So it's 1 over x squared, and obviously we've got 2/5 at the start there, and they're being multiplied together. So if we multiply those together, we get 2 on the top and 5x squared on the bottom. There we go. So again, obviously, as I said, you can leave it as 2/5 x to the minus 2, but obviously you want to be able to write this in that different way, just in case, and thinking about the progression of some of these topics, we may need to write that in a slightly different way. So there we go, having it as 2 over 5x squared there, it's good to be able to also swap and change the way that you write your answer. But there we go, there's a few questions that we've had a look at, and let's have a look for some for you to have a practice on. Okay, so there's 4 questions here, so pause the video there, have a go at these 4, and we'll go over the answers in a sec. Okay, so for the first one then. Alright, we've got 9y to the power of 10, all to the power of 3 over 2. So let's figure out that 9 to start with. So 9 to the power of 3 over 2, let's have a look. 2 on the bottom, that's going to square root it. So the square root of 9 is 3, and we're going to do that to the power of 3. There we go, because there's a 3 on the top, so that's 27. So we know the number there is going to become 27, so we can write that as 27 there. And we just need to figure out what that power of y is going to be. So again, multiplying the powers here, 10 times 3 over 2, or we could write that as 10 over 1 times 3 over 2, and that becomes 30 over 2. And 30 divided by 2 is 15. So that's going to become 27y to the power of 15. And there we go, there's our first one. So let's finish that one there. And let's have a look at our next one. So just below that, we've got a very similar question. We've got a negative power on the outside. But again, let's treat that in the same way. We've got the 16 at the start, and that's going to be to the power of negative 3/4. Now obviously we've got a 4 on the bottom. We've got a negative, so we are going to do the reciprocal. But to start with, I'm going to do the 4th root, okay? So the 4th root of 16 is 2. And we need to do that to the power of 3, as we have a 3 on the top, which becomes 8. Now obviously that is a negative power, so that is going to then become 1 over 8. So that 16 there is becoming 1 over 8. So let's have a look, let's write that down. We've got 1 over 8, and we need to figure out what that power of x is going to be. So again, multiplying the powers, and 4 over 1 multiplied by that negative 3 over 4. On the top there, we have obviously it's all going to be negative because we've got a negative there, but on the top we have 4 times 3, which is 12, 1 times 4, which is 4, and there we go, 12 divided by 4 becomes 3, so we have negative 3 as our power, and there we go, minus 3. So again, this is one of those questions where we can write it in a different way. Hopefully you also looked at that, but x to the power of negative 3 can be written as 1 over x cubed. There we go, and obviously we have an 8th there, so we've got 1/8 times 1 over x cubed On the top there we get 1, and on the bottom there we get 8x cubed. And there we go, there's our final answer. So obviously for that particular question, there are two different answers that you can write. You can either write 1/8 x to the minus 3, or you can have the 1 over 8x cubed. Either one of those is absolutely fine as an answer. Over to the right then, we're going to simplify this, so we'll deal with what's in the bracket to start with. So we have 2x to the negative 1/4 to the power of 4. Now 2 to the power of 4, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So we have 16 inside there when we've got that 2 to the power of 4. There we go, let's just write that down. And then we've got to deal with that power of x. So that's going to be x to the power of, and we have 4 times 1/4. 4 times 1/4 is 1, so it's just minus 1. There we go. And then not forgetting that we've got the x on the outside that we still need to multiply in. Now, not forgetting here that obviously there isn't a power of x there, which means it's a power of 1. So if we multiply this in, it's 1x to the power of 1, so 1 times 16 is 16. And then x, and we're going to add these powers together. So we've got 1 and negative 1, and that makes 0. There we go, so we've got 16x to the power of 0. Now obviously not forgetting, again, x to the power of 0 equals 1. So actually what we've got here, we've got 16 times 1, and that is just 16. So our final answer for that one is just a whole number 16. There you go, a nice little interesting one there, where actually all these x's have just disappeared. Okay, on to the last one then. We're going to treat it the exact same way as the one above. So dealing with what's in the bracket first, 3 to the power of 3, or 3 cubed is 27. So we have 27 in the bracket there, and then figuring out that power of x. 1/3 times 3 is 1, so again we get negative 1 there. And again that's in a bracket, and when this time we have an x squared at the start to multiply in. So again that's 1x squared, so we have 1 times 27, which is 27. And then we're going to add the powers of x, so negative 1 add the 2 is positive 1, or 27x to the power of 1. Now obviously we don't need to write that power of 1, so we can just write that as 27x. There we go, and there's our final answer to finish off these questions. Right, there we go, so let's have a look at something slightly different and start to make these look a little bit more complicated. Okay, so this question here doesn't look very nice at all. But again, we're just going to treat it exactly like we have done in the previous questions. We're going to deal with the top, and then we'll have a look at the fact that it's a fraction. So that top bit there can simplify. So straight away, let's have a look at this. So on the top, we've got 2 to the power of 3, which is 8. And we're going to multiply those powers. Okay, so 3 lots of 1/2. And then again, you can just write that as 3 over 1 times 1/2. And you get 3 over 2, or 3 halves, there we go. So that's 8x to the power of 3 over 2. On the bottom, nothing simplifies there, so we'll just leave that as 4x squared. There we go. And now all we have to do is simplify this down. So looking at the numbers, we've got 8 divided by 4. 8 divided by 4 is 2. And then we are dividing with these powers of x. So when we're dividing, we take away the powers. So we've got 2x to the power of something. We just need to figure out what that is. So obviously what we've got there is we've got 3 over 2. And we need to take away 2. So we're going to take away 2. Obviously 2 is 2 over 1. If we want to write that in terms of halves, we'll have to just change that denominator there. Just obviously that'll become 3 over 2. Take away, and if we times both of these by 2, there you go, that becomes 4 halves. And when you take those away, you get minus 1/2. There we are. So just taking away those powers there, and you might be okay just doing that without obviously writing all the fraction working out, but obviously just to show you there that you can just obviously apply a bit of written methods as well. But there we go, we get 2x, and our power is going to be minus 1/2. And again, you might be able to just do 3 over 2, take away 2 in your head, but there we go. So 2x to the power of minus 1/2, and again, that is a final answer there, and we can leave it like that, but there's another way that we can write this. And obviously this is going to be important for thinking about it in reverse as well. So x to the power of minus 1/2, well, x to the power of 1/2 is the square root of x. So that would be the square root of x, but it's a negative 1/2, so that'd be 1 over the reciprocal of that, so 1 over root x. So actually what we've got here is we've got and 2 multiplied by 1 over root x. There we go, and don't forget 2 as a fraction would be 2 over 1. So multiplying the top there, we get 2 on the top, and multiplying the bottom, we get the square root of x. So again, two different ways of writing your answer. You can either write that as 2x to the power of minus 1/2, or 2 over the square root of x. Either one of those is absolutely fine. Although I do think it's important to be thinking about how you can write your answers in different ways, purely because, as I said, sometimes they might be going the other way round, or you might have a square root on the bottom and have to rewrite it as a power. So it is important to be able to write them this way. Now let's have a look at another one. Okay, so this one here is probably the nastiest looking one out of the bunch. It says, write 5 plus 2 root x all over x squared in the form 5x to the power of p plus 2x to the power of q, where p and q are constants. Okay, so then we've got this word as well, constants here, which obviously at GCSE level you see the word integer there quite a lot. It means a similar kind of thing. It's going to be a number, but a constant means it doesn't necessarily have to be an integer, so it doesn't have to be a whole number. But it does mean that there are two set numbers here that they are going to be, but that word constant just tells us that they don't necessarily have to be integers. Okay, so that's all that means, so don't be put off by any of these words. All we're going to do is figure out how we're going to approach this. So first things first, obviously we've just looked at in the previous question, we've got a root x here, and there's another way of writing that. So if we write this out in a slightly different way, we could write it as 5 plus 2x to the power of a half. Obviously that square root can be written as a power of a half, and that's all over x squared. Now for the purpose of this, because that x squared is under two different elements on the top there, I'm going to split this fraction up down the middle, and I'm going to write it as two separate fractions being added together, all over x squared. So let's have a look what we've got. We've got 5 over x squared, so we've got 5 over the x squared, and we're going to add to that the other one, 2x to the power of a half, which is also being divided by x squared. So from here, all I need to do is apply the same logic that we have on some of the previous questions. I'll start with the first one on the left, okay, and we need to divide 5 by x to the power of 2. Now, there's a couple of different ways that you can approach this, okay, there's different ways of writing it, but I'm going to imagine, look, what power of x is actually on the top, and obviously there isn't a power of x there, so that would be x to the power of 0. Now if we subtract the powers here, obviously there is a 1 in front of the x squared there, 5 divided by 1 is 5, and then x to the power of, and we've got 0 on the top, take away 2 on the bottom, so that's going to become minus 2. There we go, just taking away the powers. Again, there is another way you could think about it. X to the power of 2 is the same as x to the power, we've got the x on the x squared on the bottom, and that's the same as x to the power of minus 2. We've got 1 over x squared, so we've actually got 5 of those, so there's 5 on the top. So you can think of it that way as well, but I'm going to just apply this little method here where we've got x to the power of 0 on the top. I think it makes it quite nice and clear with the subtraction of the powers there. Then we've also got the second one, so let's have a look at that. Now again, there's a 1 in front of the x squared, so we've got 2 divided by 1, which is 2, and then we need to subtract these powers. We've had a scenario like this earlier, we've got a half, and we need to take away 2, and we wrote that earlier, 2 is 4 halves, there we go. So when we take them away, we get negative 3 halves. There we are. So my power there, when I take them away, is going to give me x to the power of negative 3 over 2. And there we go, there's our final answer. Now again, we don't have to try and write this in a different way because it actually wants it written in this form. Look, it says at the top 5x to the power of p plus 2x to the power of q. So we've found p is negative 2, just shown here, and q is negative 3 over 2. So there we go, there's a question where obviously it doesn't look very nice, but it does actually want us to write it in a particular format, and we've actually done that. We don't need to think about writing it in a different way. But there we go, that's quite a nasty looking question, and here's a couple for you to have a go at that are similar to these two. Okay, so here's our last two questions to have a look at on these. So pause the video there, have a go, and we'll go over the answers in a sec. Okay, so for this first one then, we've got 3x to the power of 3 over 2, all to the power of 3 on the top. So we need to simplify that before we go about this division. So on the top there, 3 cubed is 27, so we've got 27 in the bracket, and then we've got x to the power of, and let's multiply these powers here, and that becomes 9 over 2. There we go, so the power of 9 over 2. Again, just remembering, we've got 3 over 2 multiplied by 3 over 1, which makes 9 over 2. So there we go, that's where we've got our power from. And that's all being divided by 9x to the power of 4. Now if we go about simplifying this, look, we've got 27 divided by 9, which is 3. And then we've got x to the power of something. We obviously just need to subtract these powers. So we have 9 over 2, and we want to subtract 4, which is 4 over 1. Now obviously doubling the top and bottom there, that'd be 8 over 2. So I could just rewrite that as 8 over 2, that 4 over 1. And when we take those away from each other, we get 9 take away 8, which is 1, and then that's over 2, so it's a power of a half. So we get 3x to the power of a half. And again, that is a fine answer to finish up on, but obviously for the purpose of this, we're going to also look at how we can write that in a slightly different way. And x to the power of a half is the same as the square root of x, so we could also write this as 3 root x, okay? And either of those are perfectly fine answers, but again, just thinking about those different ways that we can write them. There we go. So on to our last question here on the right. We have quite a lot of little bits to deal with here. Now, first things first, I want to rewrite this root x as x to the power of a half. So if we go about writing this out again, we've got 10x, and we're going to take away the other one. Now, just thinking about this, I'm going to split this into two fractions in that first step. I'm going to write this up here, that is x to the power of a half, just to save on all these different steps and filling up the screen too much. We'll just go with that. So we've got 10x over x to the power of a half. And then we also are going to then take away, we've got 5x to the power of 7 over 2 on the top, divided by x to the power of a half. There we go, and now we can go about simplifying them. So the left one there, don't forget that's 1x to the power of a half, so 10 divided by 1 is going to equal 10. And in our power of x, we've got a power of 1 on the top, take away the half, so that's going to be the power of a half. And then we're going to take away, and again we've got 1x to the power of a half on the bottom, so 5 divided by 1 is 5, and then we've got x to the power of, and we've got 7 halves, take away 1 half, which leaves us with 6 halves. There we go, and let's write this to the side. We've got, in fact, let's just write it here, or I can write it out again. There we go, 6 over 2. Now obviously we just need to finish that off because 6 over 2 does actually become a whole number there, it becomes 3. So we just want to write that out, obviously without that power of being 6 over 2, so we've got 10x to the power of a half, take away 5x to the power of 3. There we go. And just check back to the question, it said write it in the form 10x to the power of p, take away 5x to the power of q, so we have done that. And again, it said that they're going to be constants, they're not necessarily whole numbers, and as we can see, we've got the half as one of the powers there. So that's absolutely fine as our final answer. P is equal to a half, and q is equal to 3. But there we go, that is some of the work on index laws. As I said, a lot of the stuff from GCSE is really, really important still, and whether you're taking A-level maths or whether you are doing further GCSE further maths. So I will link below all the really important videos on this topic that you still need to make sure that you are having a look at and making sure that you're really happy with, obviously, if you're sitting either of these GCSEs or A-level exams. But there we go, that's the end of the video. Hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.